We just got a 7.0 earthquake in Japan. 7.0 earthquake has just occurred in eastern Japan, near Sendai, basically almost in the same area as the 8.9 that occurred on March 11th, 2011. So basically, yeah, so basically there was just been a large earthquake in Japan, 7.0, depth of 54 kilometers. Actually, it was literally not on the water. It was like right on the shore. There was just a 7.0 earthquake. Just saw a video on social media. Someone posted an earthquake during a wrestling match in Japan. That's how I found out about the earthquake on the USGS website. The earthquake actually occurred in the last hour. Um, if you go on the USGS website, it will still show red, I believe, at the moment, which red means in the past hour. Also, the Krasavik volcanic field, Flick. I can't even pronounce the name of the volcano because I don't know how to speak Icelandic. Yeah, so basically that volcano also went off. Even though that particular volcano, the Fleck, that fissure hasn't erupted in 6,000 years. That volcanic, it's nevertheless the first eruption in that volcanic field in over 800 years in Iceland, but thankfully it's only a very fluid basalt, and it occurred in an area that's just going to allow the lava to harmlessly drain out to sea. So there's been an earthquake in Japan, a 7.0, um, on the subduction zone on the Eurasian and Pacific plate boundary. The tectonic, it occurred at a depth of 54 kilometers, likely could have been on one of those fractures that you have. It didn't occur right at the where the subduction occurs. It was further deep, so it might have been more of a thrust, not a thrust, but a strike slip. Sometimes you get strike slips along the subduction zones. That's in those deep earthquakes is actually how magma gets formed. That's part of the dehydration process of those of of the deeper crust, and this dehydration process is how water gets released and allows the oceanic crust to melt. Basically, water actually changes the chemical composition of the rocks and lowers its melting temperature. In fact, the stagnant faults under the North Korean Chinese border is actually what's responsible for not only Mount Chengdai, the super volcano, but also nearby volcanic fields. It's actually formed by the stagnant Pacific plate boundary, and there's actually been dehydration quakes. So the same thing that forms a subduction-driven volcanism. There's enough water in the stagnant Pacific plate, at the mantle transition zone, that actually there's a lot of melt that occurs from the mantle transition zone because of dehydration processes that allows for some of the melt to rise towards the surface and form that volcanic field in the border of North and South Korea. I mean, North Korea and China. Mount Chigbai is actually andesite type magma. It's the same type of process that you get. It is subduction driven. This is, because of dehydration processes, just well east of where most of the subduction driven volcanoes occur. Japan's quake was 7.0. I'm going to look up the quake type. I do not think it's going to be a thrust. I think it's actually going to be strike slip or normal faulting. I'm going to go check right now and I'll tell you what it is. So I looked at the moment tensor and it is subduction. Very likely deeper subduction, but it was indeed subduction. There was um, a large blue oval in the middle of the moment tensor, which means it was subduction. It was a subduction quake. So if you get So if you get a white oval surrounded by blue, that is a reverse faulting. But if you get an like a timer shape, that is strike slip. So for example, you can get um, hybrid strike slip and thrust, or you can get fully strike slip where it looks like a like an hourglass figure, or if it looks like an a blue egg shape, that's thrust. If it looks like a white egg shape, that is rifting or the opening of the ground. That's called normal faulting. Usually, you'll find that in grabens. Sometimes you'll find normal faulting. You'll also find normal faulting along a rift faults. So this quake was indeed subduction. It was a 7.0 at a depth of 54 kilometers. So that is pretty deep. Though it did occur on the North American and the Pacific and Eurasian plate boundary, it occurred pretty deep. And because of its large depth, so far the earthquake, from what I can tell, has not been very destructive. I'm going on social media and finding out. So you will see you'll see me like not talking for a bit. That's because I'm going on social media. I'm gonna go back on Twitter and see what is going on. Um, yeah, I believe that hopefully no. Good news is that so far there's been no reports of injuries in Japan, but I'm still gonna look again. Hold on. And thankfully, the volcano in Iceland erupted in a harmless area. All right, I'm going to bed now, guys. I'm getting really tired. I gotta get up in a few hours to go to work. Hold on. Before I go to bed, I'm gonna. It's weird.